Good evening. Just finished the interviews here, so that's why I was here tonight. So I'm going to answer your questions that you had about this probability stuff, probability and odds, and things like that. And I can understand that this stuff can kind of be quite confusing at times. So let's pop open the board here, and we'll walk through the ones that you kind of put up there and see how that goes today, and see if it'll help you out a little bit. Okay. Hopefully it will. And so the first one is this number 12 on page 310, which talks about odds. And it's talking about odds about three different topics: wins, losses, and ties. So what we're going to do is we're going to break it down into wins, losses, and ties as we read the question and then see if it makes any sense. Okay. So the first thing it tells us in the question goes, a coach for a basketball team claims that for the next game, the odds in favor of the team winning are 3-2. So that means there are three favorable calls, which are wins, and two that are not. Now, those two that are not aren't necessarily losses. They could be ties or losses. Okay? So that's the first part of it. So this is number 12. Okay, so 3-2 for wins. So this means that this part is favorable, and this is unfavorable. Okay, and then the total is 5. Okay, so this tells us the favorable of this, it says 3-2 that they're going to win. So that favorable means a win. This could be a tie or a loss. So that two of them are ties or losses. So what we know is that the team wins 3 out of 5 games. Because remember with odds, it's not the total, it's the favorable to unfavorable. So that's the first statement. The second statement says, the odds in favor of the team losing are 1-4. So this is for losses, 1-4. So this is odds in favor of losing. So this is losses, and this is either wins or ties. Okay, so we can see that for losses, this is wins here. There's 3 out of 5 wins. For losses, there's 1 out of 5 wins. Or sorry, losses, pardon me, not wins. This is wins. So 3 out of the 5 are wins. 1 out of the 5 are losses. And the last one is odds against. So they flip it around on you. Odds against a tie are 4-1. So if you wanted to flip it around and say odds for a tie, you could flip that around. So odds for a tie, ties against a tie is 4-1. That means this is a win or a loss, and this is a tie, because that's the unfavorable one. Ties against. So that would mean that in terms of ties, there's 1 out of 5 are ties. So they're asking you, does this make sense that you could say, does this add up to 1? There's 3 wins out of 5, 1 win or 1 loss out of 5, and 1 tie out of 5. Does that add up to 5? So 3 out of 5 plus 1 out of 5 plus 1 out of 5 would be 5 out of 5. So yes, this does make sense. It does because, what the heck? My marker's going all over the place here. Yes, it does make sense because the probabilities add up to 1. Okay. right? So 3 over 5 for wins, plus 1 over 5 for losses, plus 1 over 5 for ties gives you a 5 over 5, which is 1. Okay, so that one does make sense. Okay, the other question that you may, hopefully that helps. Okay, remembering that odds is not like probability. Probability is favorable over total, whereas odds are favorable versus unfavorable, or unfavorable versus favorable, whether it's odds for or odds against. So you have to be careful with those two. Okay, so the other question that you had is like looking at page 321, which is the next section, and it asks, you're asking me, how do you do number 5? Okay, so number 5 says, access to a particular online game it is password protected. Every player must create a password with 2 capital letters followed by 3 digits. For the conditions below, determine the probability that the password chosen at random will contain letters S and Q. Okay, so that's a basic specific idea. Okay, the repetitions are not allowed in the password. Okay, so the first thing we have to do is we have to decide how many possible passwords can we get. Now, with a password, order does matter. Okay, so an SQ is different than a QS. So this is permutations, first of all. Because password, the order of the letters and the digits does matter how you type them in for your password. Okay, so that's the first thing. So that you know you're going to use passwords. So the first step that you do in 1 is you got to find the total number of passwords possible. Okay, the total number of passwords possible. So the total number of passwords possible, repetitions are not allowed in the password. Okay, but before we do that, we have to find out the total number of passwords possible. So the total number of passwords possible would be, we have 2 capital letters followed by 3 digits. So 2 capital letters. So that would be, we have 26 letters to choose from, and we're going to choose 2 of them. Okay, and that means we're going to multiply. We're going to choose 3 digits. So the total number of digits are 10 digits. And we're going to choose 3 of them. And the reason we're taking a permutation and not a combination is because the order in which we put the digits is important. Excuse me for a second. I'm just going to pause and have to answer a quick email here. Then I'll be back. Hey, sorry about that. Okay, so this is the bottom that we're figuring out here. So we're going to take 26P2 and 10P3. So this is going to be our 2 capital letters of any kind of letter. Right now, we don't have to worry about the favorable. So this is a total path possible. So if we go 26P2, that's 650 ways to do that. And so and means multiply, 10P3. 720. So the total number of ways, if we take 720 times 650, there's a lot of different passwords we can get. We can get 468,000 passwords. Now that's our bottom number. That's a total number of passwords you can make with those combinations. Now what they're telling us is they're saying that the favorable conditions are, what is the probability that the password will contain an S and a Q, okay, and then have 3 letters after that. Repetitions are not allowed. Okay, so step 2 is to find the favorable ones. So the favorable ones we can do permutations again, or we could just do blanks because that's a permutation. If we think of it as 5 letters, so it has to be an S or a Q, so we can have an S and a Q this way, plus any of the 10 numbers, any of the 9 numbers, any of the 8 numbers. Or we could have it this way, a Q, then an S, and then 10 numbers there, 9 numbers there, and 8 numbers there. So if we do that, and we can have it this way or this way, so we have to add these two together. So if we take and calculate that, this is just one S and one Q, and one S. So there's basically these numbers. So 10 times 9 times 8 gives us 720 ways. So there's 720 ways we can do it that way, and there's 720 ways we can do it this way. So if we add those two together, we have 1,440 ways that fit the condition, that are favorable. That means that fit the passwords, because there could be any number of those letters there. So that means now to get probability, we take the favorable divided by the unfavorable. So 1,440 divided by 468,000, like that. Pardon me. Okay, so now if we do that, what do we get? 1,440 divided by 46800, 0. I get 1 over 325 if we do it as a fraction, which if we do as a decimal, it's 0.00307, something like that. So that's how you do that probability there. Okay, so the trick there was you have to get the bottom number, which was choosing 2 letters where order matters and 3 numbers where order matters. Now, if we did it with blanks, you could have done it with blanks too. If you did it with blanks, it would have looked like this. That would have been any letter, any letter, any number, any number, any number. And if you go 26 times 26 times 10 times 10 times 10, oops, I'm wrong. Oops. We have to, sorry, I guess it says we cannot repeat them, so I have to change these down here. So, pardon me. I guess we can't have, I forgot, there's no repeat. So this one has to be a 25. Don't want to lead you down the wrong path here. So these ones have to count down because we can't use the same letter twice. My mistake there. Almost. Right? So if you're not using the same letter twice, you have to go 1 letter less. If we have not the same number, 1 number less, another number less. So if we did that one, then we get the same number as we had before. Okay? So, because this is without repeats. When it says repeats, we're going to have to change. Okay, so that's how we got the probability of that. So this is step 3, probability formula. Okay, the B part, we have to change this whole setup now. Okay, in B it says repetitions are allowed. So if we do repetitions are allowed, that's what I was doing originally. So rather than do permutations, let's just do blanks. So if repetitions are allowed, we have to have, we could have any of the 26 letters there. We can have the same letter repeating twice, right? And then we can have all the numbers repeating. So that's going to be our total outcomes for the password. You could have any of the 26 letters, any of the 26 letters, and any of the 20. So that would be 26 times 26 times 10 times 10 times 10. Okay, so that's going to turn out to be 676,000 on the bottom. Okay, now that's the total outcomes. That's step one. Okay, now we know the favorable outcomes. It says repetitions are allowed in the password, but it tells us we have to have an S and a Q and then 3 letters. So we can have an S and a Q, which would be 1 each, and then 3 letters where we could have repeats. So this would be 10, 10, and 10. Because those letters can repeat. Now the other one that we could have is we could have a Q and an S. So there's 2 cases here. And we'd have 10, 10, 10. So this time, rather than counting down, like we have 2 possibilities there, 10 times 10 times 10, which is our 1,000. We have 1,000 ways there. We have another 1,000 ways here. So we got to add those 2. So there's 2,000 favorable outcomes. Okay, so then if we do our probability now in the step 3, this would be 2,000 divided by 676,000. So if we go 2,000 divided by 676,000, we get 1 out of 338. Or if you don't like a fraction as a decimal number, 0.002959. Okay, so that's kind of how number 5 works. Okay? So that the probability adds a lot of different calculation there. Okay, so what we were doing basically in this one was we're looking at the total number of outcomes over the favorable outcomes. And the favorable outcomes is having an S or a Q. You can have an SQ or a QS. So there's 2 cases. And then you could have any of the 10 numbers after if repeats are allowed. Okay, hopefully that one helps you. Okay, the other thing you asked me about was 8. I know this is kind of a long video, I'm sorry, but we'll go through 8 as well, okay? We'll see, hopefully it'll help us. Okay, let's read 8 and see if we can figure some stuff out. Okay, 8 says, a student council has 15 members, including Yuku, Luigi, and Justin. The staff advisor will select 3 members at random to be treasurer, secretary, and liaison to the principal. Determine the probability that staff advisor will select Yuku to be treasurer, Luigi to be secretary, and Justin to be a liaison. So there is only one favorable outcome, that particular one that they told us. So we know that there is only one favorable outcome. Okay, so this is number 8 on page 322. So they're telling us that they're going to have a specific job. Okay, there's a treasurer, a secretary, and a liaison, and each one of those people are going to get that. So there's only one favorable outcome. Okay, so that's like our step 2. We know one person is this, one person is this, and one person is this. This and this and this. So 1 times 1 times 1 is still 1. Okay, but what is the possible number of outcomes? Okay, so that's what we have to find. So the possible number is you're going to pick 3 students from 15. Now, does the order in which they are selected matter? And the answer is yes, because there are 3 different positions. So you can select that person for a particular position. So the order matters. So when order matters, we use the permutation formula. So we want to select from 15 people, we want to select as a permutation 3 people. So if we do 15P3, we get 2,730. So then our probability of selecting those people should be 1 out of that number, 1 out of 2730, which is a very small number. 0.0036663. Okay, so that's the first probability one. Okay, now the next question is a tricky one. It says, the staff advisor will also select 3 members at random to clean up after the pep rally. Determine the probability that that staff advisor will select those 3 people. So there is only one way to select those 3 people again in that cleanup committee. But now we're not going to use a permutation for B. We're going to use a combination for B, because the combination, the order that they're selecting doesn't matter. If they get selected first, second, or third, doesn't matter. They're still cleaning up. But in the first question, it mattered if they got selected first, because then they were the secretary, rather than second, which they ended up being whatever it was there. Oh, sorry, the treasurer was first, then the secretary. So in this case, instead of doing 15P3, you're going for our bottom number in B, we're going to do 15C3. So there's 1 favorable, but pardon me, but the total number of outcomes is going to end up being 15C3, because they are now on a cleanup committee and they're not in a particular place. So if we go 15C3, we end up getting 455. So we get probability equaling 1 over 455, which would be, okay, 0.002198 or so, or this fraction. Okay, so the key there, if you're looking at that, the key there is recognizing the difference between a permutation for the bottom number or in a combination for the bottom number. Okay, so I'm just going to pause here before I do the next one, have a little drink here, and then we'll do the next one. Okay, had to have a little water there. Okay, so very long video. My apologies. Okay, hopefully I'm not confusing the heck out of you. These can be a challenge at times. Okay, the last one here is a student count that you suggested was 10. The student council has 16 boys and 16 girls and 7 boys. To form a subcommittee, 5 students are selected at random from the council. Determine the odds in favor. This is not probability, so you have to be careful. The odds in favor of 3 girls and 2 boys being selected. Okay, so the first thing we have to do is we have to realize that this is a combination problem, because it doesn't give us specific jobs for each person selected, it just says a committee. So we know that it's a combination problem. So that's first. It uses combinations. Okay, the second thing is we want to find out how many ways can we select 5 students from the whole group. Okay, so we need the total of the group. So we have 16 girls and 7 boys. That's 23 in the group. And we're going to select 5. So 23C5, that's going to give us the total number of outcomes. Okay, it's not going to give us favorable and unfavorable. It's going to give us the total number of outcomes. So we take our calculator, we do 23C5. Okay, so that's 33,649. Okay, now what we want, this is the total number. Now we want favorable outcomes. Okay, so what they're telling us is we want 3 girls and 2 boys. So 3 girls and 2 boys. Okay, so 3 girls. The girls are coming from the 16. So we're going to take 16 girls and we're going to select 3 of them. And means multiply. We're going to select 2 boys from 7. So 7C2. So we work out both of these. So if we go 16C3, it's 560. And if we go 7C2, it's 21. So this is going to give us a number of ways that we can select 3 girls and 2 boys from that group of kids or people, I guess. So 21 times 560 is 11,760 ways, favorable ways. Okay, so now we have to be careful about the type of question. It says, what is the odds in favor? So these are favorable ways. Now we have to get unfavorable ways. So the way to get unfavorable ways is to subtract the total number of outcomes, subtract the favorable outcomes to get unfavorable. So we're going to have to find the unfavorable outcomes. Okay? So 33,649 total, subtract 11,760 favorable. This is going to give us unfavorable. So let's take our calculator out. Go 33,649, subtract 76. Oh, what am I doing? Sorry about that. 33,649, subtract 11,760. All right, so this tells me I've got 21,889 unfavorable ways. Okay, so how do we do odds for? That's favorable versus unfavorable. So we have to take this number against this number. Let's do it. Okay, and it might reduce. Let's see. I'm going to try reducing it. My calculator does it automatically. It's kind of handy for reducing. Mine does reduce it down to 1680 over, or 2, 3127. Now, we just spent a good half an hour going through those, so I can understand if it was challenging for you, and that's fine. These things rarely go smoothly the first time. So if you look at which one did we do there? That was number 10. If we look at number 10, they do give it in the right form. Okay, so they did give it with a quote there. So that's good, rather than a decimal. So odds are usually just written as a ratio like that, whereas probabilities can be written as a decimal. Now, I'm going to send this video off to you. It may help you. It may not. If we're still struggling a little bit, maybe we should do a few more, or I should give you a few more examples. You let me know how it's going. I realize that this can be quite a challenging area. Okay, so good luck. Watch that through. Hopefully it'll help you out. If not, you just let me know, okay? Good luck.